Hi Pre-Calc, welcome back. I hope you all are well. Our objective today is going to be to review piecewise functions. I've got the checklist on the screen. You know what to do from here. All right, I'm going to force pause on your screen. Can you please copy example 1 in your notes and then we'll work it together. Okay, we're back. So we want to evaluate f of x, which is y, right, at these three x values. Remember that if this is a function, which it claims to be, right, f of x, then there can only be one output for every input. So for each one of these, I have to determine, am I going to pick the top piece or the bottom piece? And the way we determine that is looking at our x values and seeing, okay, which inequality does it fall into, right? Okay, so a -1, would that be an x that is less than 0 or an x that is greater than or equal to 0? That would be an x that's less than 0, right? So I'm going to focus in on the top piece. I'm going to plug in -1 for x using that expression, okay? So I've got absolute value of -1 minus 2, which is the absolute value of -3, which is +3. Okay, so in this case, f of -1 is 3. If we were looking at the graph, this would translate to the ordered pair -1, 3. Okay, all right, for the next piece, f of 0, do you want to use the top piece or the bottom piece or both? So we're never going to use both, right? Because again, we want just one output. In this case, we're going to use the bottom piece because 0 would satisfy that inequality. So that means I'm going to grab this expression and plug 0 in for x there. So I'd have 2 times 0 plus 3, which is going to be 3. All right, I'm forced to pause on the screen. Go ahead and try the last one on your own. Hit continue when you're ready to see the answer. So we should have gotten 5 because 1 is greater than or equal to 0, right? So we want to use the bottom expression once again. All right, let's try this one together. Would you go ahead, you don't need to copy the graph in your notes, but I'm going to force pause on your screen just to write down f of 0, 1, and 2. We are back. So in this case, same idea, it's just that I'm giving you f of x graphically as opposed to analytically. So remember that this is f of x, so that's your x value, and this means what is y when x is 0, right? So when x is 0, I'm going to come and find my y value there. So f of 0 is going to be 3. All right, for f of 1, would you use the red part of the graph or the blue part? And the green dotted line is just a guide for when we were graphing. We would use the blue part because of the closed circle there, okay? Remember, closed circle is analogous to the line that we had for that expression, for that inequality there, okay? So we are going to use the blue piece here. So when x is 1, y is 0. We would not use that ordered pair because of the open circle, okay? So that point is not on the graph. Okay, for f of 2, would you use the red piece or the blue piece? We would want the blue piece, so when x is 2, y is, once again, 3. Force pause on your screen. Can you please copy example 3 in your notes and give yourself some room to graph as well? Okay, so now we're actually going to kind of review graphing piecewise functions. And what we're going to do is graph them in their two pieces, okay? So I'm going to start with the top piece, which is x plus 1, valid for x is less than -1. Now for this top piece, would you do an open circle or a closed circle? We're going to have an open circle because it's strictly less than, as opposed to what you see on the bottom here, which is greater than or equal to. Okay, so when we have that or equal to, we'll have the closed circle. Otherwise, it'll be an open circle. Okay, so let's go ahead and just graph that line as if we didn't have the inequality there. And then what we're going to do is erase the x's for which that expression is not valid, all right? So let's go ahead and just graph the line y equals x plus 1. So y-intercept of 1, and then a slope of 1 as well. So I can either go up 1 to the right 1, or I can go down 1 to the left 1, right? Let's just go ahead and plot a nice long line for this entire plane that I have here, okay? And now let's go and erase what I don't want to include. So remember that this top expression, y equals x plus 1, is only valid for x's less than -1, okay? So what I'm going to do is kind of draw a little guide here at x equals -1. And do you want to erase everything to the left of that or to the right of that? We want to erase everything to the right of that because we only want to keep the x's that are less than -1. So I want everything to the left to stay, but everything to the right to go away. Okay, now let's come back. We said we do want an open circle at -1, right? So be sure you go all the way up to -1. One of the biggest mistakes I see is like students will start with like -2. Be careful there, because then you get this way too big of a gap, because we do need to cover all the values between -2 and -1. We just don't want to include x equals -1. So just scooch right up to it, put your open circle at x equals -1. All right, for the second expression, notice that it is valid for x is greater than or equal to -1. I'm going to do this in blue. So open circle or closed circle for the bottom expression. This will be a closed circle, right? Because of that equal sign there. All right, so again, I'm going to go ahead and graph the entire line on the graph paper that I have, and then we'll just erase what we don't want to keep, okay? So for this one, we have a y-intercept of 2. This time we have a -1 slope, right? So we can go down and to the right, 1 in each direction, or we can go up and to the left, 1, right? So let's see if I can connect these. Okay, now again, I've got that guide, still that dotted line. Do you want to keep everything to the right of the dotted line or keep everything to the left? We want to keep everything to the right and only the right. Okay, because we want x's greater than or equal to 1, and then come back and make sure you've got a closed circle here, okay? Now, a few things I want you to verify when you're doing these. Always make sure, always make sure, does your graph pass the vertical line test? In other words, if I draw some kind of vertical line, any vertical line, will it cross only once? Yes, it will. So we're good there, right? You really want to make sure on that guide that we drew, this guide here, that you've got no more than one closed circle, right? Because if I were to close both of those, now we wouldn't pass the vertical line test at x equals -1. So please double check those as you're graphing these yourself. Again, that's another, that's a quick spot for a teacher to see, okay, this is not graphed correct because maybe I have something going like that and I've got, kind of two lines, one underneath the other. So double check for vertical line test. Here is another question for you. The given function that we've drawn, is it continuous or discontinuous? This would be discontinuous because I would have to pick up my pencil to draw it at -1, right? Now, since it's discontinuous, can you classify the kind of discontinuity? Would you say this is removable or non-removable? This is going to be non-removable because I can't move or patch it up with just one point. This is in fact a jump, okay? It's what we call this particular kind of non-removable discontinuity. Now here is a question for you. Could we determine that this has a non-removable discontinuity without ever looking at the graph? So if I would have like hidden this all together, let's see if I can do that. Could I look at just this part and say, oh, I know that that's going to have a non-removable discontinuity? Well, we can. Let me show you here. If we plug in -1 for x to the top piece, we would get 0 for y. And if we plug in -1 for x into the bottom piece, we would get 3 for y, and those y values are not the same. That's what creates that jump where you have one that has a closed circle, one that has an open circle, which is how we would show this in calculus. Okay, so you can verify here that you've got, that y value of 0 and the y value here of 3, which are called limits, and we will get to that in a couple months. And force a pause on your screen. Can you please try this one on your own? And then also decide whether or not f of x is continuous at x equals 0. And then when you're ready to see the answer, go ahead and hit continue. All right, so here's what we should have gotten. Is this function continuous at x equals 0? Yes, it is. Notice I can draw that without picking up my pencil. By the way, that closed circle is always going to fill in the open. And can we check for continuity without looking at the graph? Absolutely. Again, just plug in 0 for x into the top piece. You would get y equals 0 there. Plugging in 0 for x into the bottom piece would give me 0 there as well. So since those match, you get, and since we filled it in here as well, you do get this nice continuous function. All right, that's all I have for you all. I will see you next time.